what I've done to make the equipment do this stuff. So it's relatively simple. Schematic over here. The way I have it is starting in the same row. I'm going to call it this row. I have one resistor coming down to this arbitrary row down here. And then I have a second jumping this gap and going to a different arbitrary row. This one, I then have a second resistor. And then this one I have connected to it the potentiometer. And the potentiometer from the side kind of looks like this. And I'm hooking this side up to the top loop. And then there's a bottom loop that's in line with this one, and then another one that's even lower and off to the side. I'm using this one here. So that one is going to be connected to not some row, this row. There. All right. That's everything that's written on the schematic. Just need the power supply. So from the DC power supply, which I'm just going to say is like a plus minus. This guy is going to this row, clipped on, and this guy is going to this row, clipped on. Okay? Then, the last thing is I have a digital multimeter, and I have one side of that hooked up to this pair of resistors, and I have the second side of it hooked up to, let's go this way, that row. Okay? Does that make sense? Yeah. All right. So, for those of you who don't remember, turn it off, turn it back on, I guess. This is a DC power supply. I'm plugged into the 6-volt channel. You could use the plus 25 if you wanted, but more risk involved, so probably don't. Use the smallest one you can, is what I mean to say. Plus 6 volts, so I need to display my limits. I'm going to set this to 5 volts. Very slowly. And then I'm going to set the milliamps to 100 milliamps because that's what we consistently are going to be doing. So 100 milliamps, 5 volts. Now I can hit output on. Okay, it's producing 5 volts. It's is displaying the limit. There we go. So it's providing 5.001 or 2 volts, and it's saying it's 0.004 milliamps. That might not be accurate, but that's okay. Then over on the multimeter side, we have it set for VDC, which is this top left button. We're plugged into these top right 2 inputs because we're measuring voltage, and I have those connected up right. So now you can see we have this volts DC, and this knob, as I turn it, changes the voltage. Okay? So the idea here is we're going to set this to 0. I've used all 10 kilo ohm resistors here because that was easy. So once I set this to 0, I expect this potentiometer to read 10 kilo ohms. Am I negative now? Yes. You will go negative on this, so be careful of that. All right. That seems close enough. So now what we want you to do is disconnect it without touching the knob and measure this resistance. You're proving to yourself that this ratio is going to hold. That's the point of this section of the lab. So, why don't we have a look? So, one guy that doesn't want to stay on. Come on, buddy. Another. The holes you need for resistance are the same as for voltage. You just need to hit the 1.9. Clearly I misread those. 1.986 kilo ohms. What? Oh. One of these is not a 10 kilo ohm. This is what I get, see, for trusting the bins. Always measure your resistors when you pull them out.
I figured that out last time.
Regardless, I've got a 2 kilo ohm and okay, so that does follow then. I've got 2 10 kilo ohms. Should probably indicate this. This is a 10K. This is a 10K. This is a 2K. And so in order to have this 1-to-1 ratio that this one's here, this would need to be 2K as well, which is near enough. 1.98. What we're reading. So that's the last section of the lab. Any questions about the equipment and that last bit? Will that like finish everyone for
Actually,
last year?
with the potentiometer, what's the difference with the holes there? Like you had the two on the bottom.
Well, when you kind of got a ground and two outputs. So if you have a one of them is going to be kind of the opposite. If it's like a 10K max potentiometer, you could have like, so there's the three legs. It depends on the pinout. It changes. You need to like check. But say this one is the ground. So this will be your input, right? And the resistance between here and here will be 10K minus X. The resistance between here and here will be X.
Okay.
You see what I'm saying? So that's where the rest of it is going. So when you don't hook it up like this, it doesn't really matter. It just goes to ground, it goes wherever. But that's what you're doing. It's one or the other. And we're just setting it up this way because this way is easy. Anything else? All right. I guess let's talk about lab 3. So, Thevenin and Norton's theorem. This lab is pretty, I'm just about to start like saying problems with this lab on a recording.
Oh, I can pause it. Don't worry. That's great.
Our group left out some and that I've done circuits like this before.
Mm-hmm.
So we were lucky with the breadboard. But when I did it, my professor used to, and you're on page 7 right now?
7, yeah. Labeled page 1. Does anyone else have that problem, or is that just mine?
I think that's just yours.
Yeah.
Well, on PDF, it's actually page 8.
All right.
You downloaded it as a Word doc that it's labeled somewhat correctly.
I think I have an old version in whatever I'm in. Okay. So there is an actual problem with this one. So this is meant to be the load. Everything else is meant to be the power supply. And it's just a bit of a mess for whatever reason. So knowing what you know at this point, you could make yourself more comfortable and redraw it so it looks a bit more like this, where the load is on the far right, which would be some, weird looking thing. It would be the 6/8 and then something, and then another guy. Where would that go? Over here. Okay, so this was. But all that stuff would flip over. You can mirror image it over, but then you'll have like stuff going around everything. And it's super ugly, and this makes more sense. Was gonna draw it, not worth doing. Okay, so you're gonna set it up like this. Okay, so you got 10 volt, 5 volt. You got this other stuff. What you're gonna need to do is get the Thevenin voltage and the current, and then you can calculate what your Thevenin resistance should be. Okay. So the first thing you're gonna do, this load basically shouldn't be there. The lab is gonna imply that it should be there, but that doesn't really make any sense. So first you're gonna get the Thevenin voltage by measuring across here, okay? And then you're gonna do the same thing again, but with a short circuit and a digital multimeter in series. And then this is gonna be your I short circuit. So your VTH divided by this ISC is gonna give you your R Thevenin. All right? Okay. I would say with the 10 kilo ohm load in there, you should take a measurement, like find out what the current voltage is. It doesn't tell you to, so please make a note of that. It's gonna make this make more sense. It's not a deliverable though. So you've taken how the circuit was reacting to the 10 kilo ohm load that you have. Then you're gonna remove the load, figure out the short circuit and open circuit voltage. So the short circuit current, open circuit voltage, work out R Thevenin. Then you will be able to build a little circuit where this is set to your V-Thevenin. So you're going to set the power supply to whatever you've worked out as V-Thevenin. And you're going to get as close to you as you can with a resistor. And that's going to be R-Thevenin. And that's it. Like you can put then your RL back in there, the 10 kilo ohm, and make sure that the current going through it and the voltage across it is the same as when you measured it from here. So you're replacing 2 power supplies and 4 resistors with 1 and 1. That's the purpose behind this. So, measurements you're going to need. I'm going to say, I'm going to call it VL and IL as like VLOad original. Something like that. And then you're going to get a V open circuit and an I short circuit. And then once you've made this smaller circuit, you're going to take these measurements again and compare them. Make sure that it's working out, reasonably close. Any questions there?
No.
Okay. That is lab 3. You guys are lucky taking it with Dr. Shea. It is no AC yet. Other classes have to do the AC. It takes forever. No? Nothing. All right. Goodbye.